how did this idea of Polars came up? Like, how did you launch Polar?
That program isn't executed as you've written. The only thing the compiler guarantees is that it gives the same output as that you've written, but it will almost never execute it the way you've written it. And if it would, your programs would run much, much slower.
Polars is better suited for data scientists than Pandas. Why do you think that Pandas is still the default for many data scientists?
So in Polars, we have two APIs, the eager and the lazy API. A lazy frame is, you can think of it like a data frame, but it isn't, but it looks like a data frame.
This is probably the most complete LLM course I've seen so far, from beginner to advanced developer by Towards AI. It's basically a one-stop conversion for anyone who wants to become an LLM developer, and the course has over 90 lessons to go from beginner to advanced in the field. It's both very practical and industry focused, but also quite technical, and you will cover a lot of technical topics like RAG, fine-tuning, agents, audio, and caching. So if you're interested, check out the link in the description, and don't forget to use the code AIStories10 to get a 10% discount. Hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist at Artifact, and I will be your host. So today our guest is Ritchie Vink, CEO and founder of Polars, an open source data manipulation library, which is well known for being extremely fast and efficient. As of today, Polars actually has over 32k stars on GitHub, so quite a popular library. And we'll talk today about Richie's career, data manipulation, Polars, and the future of the field. So if you enjoyed this episode, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, Ritchie, very excited to have you here today. Before we dive into Polars and AI, can you just please introduce yourself?
Hi, thanks for having me. My name is Ritchie Vink. I have a background in software engineering, and currently I'm working on Polars for the last couple of years.
Can you tell us a bit how you got into data and AI? I believe you weren't really into data and AI when you started working. So what did you do before, and how did you get into the field?
Yeah, that's right. I had a bit of a slow start. Initially, I did physical labor for 5 years until my 23rd, and then I got sort of my act together and started doing a bachelor in civil engineering and got work as a civil engineer. And as a civil engineer, you do mostly, you make calculations on how to ensure that structural stability is maintained of buildings. In that role, you play around with Excel a lot because it helps automating your calculations. That's always the kind of stuff I like to do, but I wasn't a programmer at the time. But somewhere I've been a civil engineer for 4 years, I believe, 4 or 5 years. Somewhere in that time, I learned programming and I got completely addicted to it and started doing it in my free time. Tried to do some calculations with Python. Tried to automate some work in my day job, and later I wrote something to sort of move BIM models, so from one application to another. Before that was all manual, and there were people who have a master's degree or a PhD degree typing over dimensions from one BIM model to the other model, so that was quite wasteful. But yeah, as I got more experienced in programming, there aren't many programmers in civil engineering, and you can either like it because you start becoming one of the best, or you think, okay, I want to learn more and I want to be with colleagues that know more than I do on this subject. So I think after 2 years, I started looking around, and I was also playing with data science. I think it was sort of there was a data science hype at that moment,
Hmm.
and I rode the wave and switched jobs.
Yeah, I think we have kind of a similar story. Like I told you this before. I also studied civil engineering, and when I had one coding class, and when I took this class, I directly realized that coding was what I really liked and was the future for me. I liked civil engineering. I think there are good studies because it teaches you how to solve difficult problems. So I like that part. But then doing it as a job, it was a bit too repetitive, and yeah, I
Yeah,
really loved the programming side of things. So did a master in AI and jumped into the field. So we have kind of a yeah similar story. So what was your first AI job then? Did you directly code at Polars? What did you do before?
no,
And
no. Yeah, I don't think we called it AI that much. It was more data science. Um, when scikit-learn was quite new, a lot of linear models, a lot of trees, just learning all these algorithms that help predict, um, predict business logic. Um, yeah, I got I got. So what was my first AI job? Was that sort of or AI work? What was the question in that
yeah,
regard?
what did you do once you started learning programming? And yeah, what did you do when you left civil engineering?
Yeah, it was mostly data science before there was any. There were not LLMs then. There were not boosting trees were also not that powerful as they are now.
Mhm,
So at that point, it felt like you could still. I think AlexNet was just released.
mhm,
At that point, there was still. It was sort of interesting to find. Okay, what kind of model should fit the assumptions of the data, um, fit the business, how you call it, the business values.
mhm,
I do feel that once that field sort of matured, it got more automated, and I think nowadays boosting trees are just so powerful. It feels like you you often need to know less of the field and let the model do its magic, and uh, yeah, it's more automated. I feel than when I started. Yeah.
And so how did this idea of polars came up? Like how did you launch Polar? I guess you were manipulating data and you realized, I don't know, building a data manipulation library would be cool. How did this idea came up?
Yeah, I was always sort of tinkering with projects on the side of the stuff I wanted to learn. Could be different models, could be a silly programming language, or uh, different algorithms. And I was learning Rust that year, and I was interested in Rust, and I was looking more I was looking for a project that sort of how you call it, made Rust one of the best solutions to use it. So a lot of where low level programming was worth it. Let's put it
Hmm.
like that. Um, I was interested in the language. The language didn't have a data manipulation, a data frame library back then, and I wanted. It started with a need because I wanted to join two tables, two CSV files in Rust, and in Python was very easy. It's still very easy. Back in the day, you just use pandas, read the files, and merge them. In Rust, you had to write your own CSV reader, and or there was a more of a low level CSV reader, but then you still needed needed to decide how to type inference the types.
Okay.
And joining was also complicated. So I was like, oh man, do you really need to set up a SQLite database for this? Maybe I can write one myself. And that's actually how I started. And when I started, I got curious. What I've written, how does it perform? So I compared a little bit with Pandas, and my solution was super slow. I didn't know much about performance programming at the time, and that sort of set the first goal. Okay, maybe I can make the join faster than Pandas. So I started learning more on both. I started researching on performance programming and databases, and especially when I learned that when I learned more about databases and query optimizers, I was sort of surprised that this didn't exist in Pandas, and that a whole field of data processing was ignored. Like, the databases are decades old. They started in, I don't know, in the 50s, 60s. And query optimization is also at least 50 years old. And Pandas didn't do that. So I was super surprised there. And I thought, okay, this is something that should exist, I thought. So I wanted to make a Pandas with query optimization. And initially I still thought I could use the Pandas API, but that was already very early. I decided that this is too painful because it's very imperative. It's very hard to do any query optimizations there. And also it's very painful to find something that is, to come up with an engine that predicts what the output of Pandas will be. And so I decided, okay, we're going to do this from scratch, and we're going to make something that makes most sense to me, and most sense. Most sense.
What do you mean by query optimization exactly?
So if you write a program in C, Java, Rust, that program isn't executed as you've written. The only thing the compiler guarantees is that it gives the same output as that you've written, but it will almost never execute it the way you've written it. And if it would, your programs would run much, much slower. The same accounts for SQL. If you write a SQL query is actually very declarative. A SQL query, you're not considered with how something is done, but what is done. So you're not saying, hey, loop over this, and for every index do this, this, and this. And the reason that in SQL or in a declarative style you don't, well, for SQL it works very well, and for data processing it works very well. The reason that you don't describe how you want to do something, but what should be done, means that the program itself can take this description of what you've written. Okay, I want this to be done, and the program itself can decide how this can be done most effectively. And so a query is almost never executed the way you've written it. We do optimizations. It's very simple, is that we don't load the columns that are not needed. We try to apply filters as early as possible, because if you, for instance, have less groups in a join, or less rows in a group by, then that's less compute intensive. We make sure that subplans or subqueries are only evaluated once. If you do stuff duplicated, we make sure that it's not being run duplicated. You do expression simplification. For instance, if you have a column and you accidentally multiply it by 1, there will be a no-op.
Okay.
So you do all kinds of optimizations to make sure that this query can run as fast as possible. And because data processing often is done on a lot of data, on a lot of rows, it's actually worthwhile to take a little bit of time to take a look at this query and start investigating it and see how you can improve it.
So what you're saying here is that in Pandas, if you write some code, it will be executed in the order of which you write the code, whereas with Polars or with SQL, it will compile the code and it will give you the same output, but it will optimize it to make sure it's as efficient as possible.
Yes, and there's another difference, and that's that if Polars you use lazy frames or SQL you run the whole query, then let's say a simple example. If you write a join in Pandas, then you write in Pandas, you don't write join, but you write merge. If you merge these two tables, and let's say you have an output of 10 million rows, and after that you decide that you only want 10,000 rows. So after that you write a head or a limit. You still materialize the full 50 million rows on the join, where there were only 10,000 needed. So in Polars you would write also this join followed by this head or the limit, however you write it. But the join execution will actually stop when that limit is reached. So it's not only that you change orders, but it's also that operations can stop earlier, don't have to fully materialize. You can actually change whole join algorithms. For instance, if you write a cross join followed by a range filter, we actually recognize that this can be in a whole different join type, which is also a lot faster. You can reorder operations, you can swap operations, you can take the whole query into account and understand what's best. And if I want to explain this to a lay person, I would explain it to, let's say you have someone who you instruct to get a fork from the kitchen. You say, please give me a fork. That person is really eager and starts running to the kitchen and gets that fork for you. But you didn't finish your sentence yet, and you said you were saying, please give me a fork, a spoon, and a glass of water. If the person had waited a little bit longer until you said, okay, I'm done, then he could have optimized his path. He could have walked only once, grabbed everything at once. That's sort of the layman's explanation of it.
Yeah, it makes sense. Very, very clear. I really like this analogy. So, okay, it's if we compare Polars and Pandas, it's faster, more optimized. Are there other things that make the two libraries different? Do you see other things, or is this the main one?
There are a lot of things that make it different. Polars is stricter on data types, so we see that as a feature, that data types are predictable by the operations. So an operation should decide what the output type of a data type is. And that way your query will not fail on data type related issues depending on the dataset size. And this isn't the case in Pandas. So in Pandas, for instance, by default, if you have an integer column and suddenly you get a missing value, it changes that integer column to a float because it uses nonce for missing, which now you have an ambiguity because a none is for floating points, means not a number, but it's not the same as being missing. And you change your data types. So this stuff is something we consider a bug in Polars and should not happen. The other is that Polars is an API, but we have different engines. We actually have a GPU engine. We have an in-memory engine. We have a novel streaming engine that can run data sets that are much larger than what fits in your physical RAM. And it's also much faster than our in-memory engine. And even, so this is just released, and this is very promising. It's one of the fastest open source query engines. The other is that we also have Polars Cloud, which allows you to run your query remotely or distributed. So Polars is sort of an API with a description of what the output types are, what the functionality is, and it's backed by different engines. Where in Pandas, I would not talk about an engine. I would speak about algorithmic implementation. So every data frame is a method which dispatches to that algorithm, and that algorithm just executes and returns another data frame. So it's more of a set of methods, a set of functions, than that it goes into an engine. If you, there are of course other other tools like Dask and probably others that mimic the Pandas API and give you sort of that engine flavor, but they don't have that strong guarantee that the behavior is the same and that the data types are the same. So you will, or the order or the floating point behavior or nan order. So all these things make it that you can have subtle bugs if you switch out to to different tools or engines in that sense.
Okay, so I guess the engine makes Polars better suited for super large data set, which is always a nightmare with pandas and is very slow. On the data type, so you mentioned like if you have an integer column and you have a missing value, like pandas will put a nan, which is a float. How do you handle that in Polars then? If you don't have a float, do you have like a integer missing value? Like how do you deal with
We
that?
don't have, we have floats. We have actually more. We have a lot of data types, and by default even more. But I think in Pandas they're dependent on the backend. So in Float, if you have a NumPy backend, I don't think you have nesting data types there. But so in Polars, we every type is nullable. So every type can have can have a null. Similar to a database can have a null. And if you have floats, you can have either none or null. But yeah, so that's, every type should be able to have missing data independent of the data type.
And so based on what you say, it looks like Polars is faster, more optimized. It can handle large databases. So it looks like it's better suited for data scientists than Pandas. Why do you think that Pandas is still the default for many data scientists? And will this change over time?
Yeah, this is because of inertia. It's because Pandas has been around for a long time. It's I believe 14 years old. It had a gazillion downloads.
How old is Polars?
It's currently 5 years old.
Okay.
From the first commit. We're currently at 130 million downloads, where we currently have 11 million downloads a month. So you see that most of the downloads are actually in the future in that sense, as we're currently almost at 10% of our download history a month. So Polar actually is very popular. I'm very proud on the 11 million downloads a month. It's 1/3, a little bit less than PySpark. I believe it's 25% of PySpark's downloads. It's the same as Dask. So it's actually very popular. It's just not as popular as Pandas in that sense. And the other is that Pandas was always, if you talked about data frames, you talked about Pandas data frames. And therefore everybody integrated it with it. But a lot of libraries are trying to come back from that now, because users also ask for Polar support. But now they're looking at, okay, how can we support it without pinning a version, without having both dependencies? So they and that's where tools like Narwhals help. They try to get the data frame libraries out and just have something more that behaves like this is a data frame type instead of a physical implementation of a data frame library. So similar, like if you have typing, you would say this is iterable and has these descriptions. But yeah, pandas is very popular because it's easy to get started. But I don't think that argument. That's often what you read, but I don't think that's entirely true. There are very strange behaviors that makes it actually harder to get skillful at it. But it is what a lot of people learned, and therefore it is what you're used to. But you cannot tell me that a reset index or reset index dot transpose is intuitive, or that's no, that it's something you learn.
I think one thing that I like as a data scientist is, as you said, it's integrated with lots of libraries. So I know if I need to use, scikit-learn or Nixla or whatever, any data science library, Pandas is integrated. So is it on your roadmap to have Polars integrated with as many data science libraries as possible?
Yes, but that's what I meant with the inertia. That's something that takes time and not something you control, because that's what other libraries do, and it is happening. So we have Plotly supports Polars, PyTorch, scikit-learn, Altair. I believe all the plotting libraries, almost all the big ones. XGBoost. So there is a lot of big libraries are coming with Polars or Panda support, but you're completely right. There is Panda support is ubiquitous and is everywhere. It shouldn't stop you from using Polars though, because if you wanna, you can still use those libraries, and if you need to move out from Polars into Pandas, we made that super easy. We have a to pandas and a from pandas, so it's one method away.
Okay, very cool. And so is there other use cases where you would recommend to use Polars and others where you think Pandas is better suited, or not
I
really?
would say, I would actually say that Polars is for 98% of the use cases, and only when you cannot do it. But even if there is a source you can only read in Pandas, I would still recommend to read it in Pandas and go into Polars, because I think you will get less type-related bugs, more performance, better readability, and also more. You get our expressions, so you get a lot more versatility. The Polars API allows you to do more without using Python lambdas. That's another benefit I haven't mentioned yet, but it's a big one.
And so earlier in the conversation, you mentioned Polar Cloud. Can you talk a bit about this? Is that your main product? Is that how you plan to build a company and make money out of it? And what is it? How does it work?
Yes, that's indeed right. As a so Polars open source is that's the Polars project, and that focuses completely on single node engines. So that's where the streaming engine, the GPU engine, the in-memory engine is. And with Polars Cloud, I want to make it easier to either productionize queries. This is similar, like if you have a SQL query, you have your SQL query, for instance, in your notebook or in your small script or in your Airflow tag. You can send it over to a server, and the server does the number crunching. This is what we want with Polars Cloud. You can have a very small machine, a cron job every day, for instance, that wants to run a query and in an ETL-like fashion, and you want to run this query, let's say every day, but this query takes a lot of compute. Then with Polars Cloud, you can say, okay, run this query on this machine, and we spin up the hardware for you. We spin up the machines, and we scale out. So the goal with Polars Cloud is to scale to any dataset that fits PySpark. So we're also building a distributed engine. And we will do both. We will do horizontal scaling and vertical scaling, and I think we will be very efficient because we're focusing on the performance of a single machine. That's our initial focus, and with the new streaming engine, you can run almost all queries. So most queries don't exceed the terabyte scale that people use, and those queries are best off on a single machine with the streaming engine. So yeah, it will be more snappy for users who aren't currently forced to use PySpark. They will be able to scale vertically. We'll have a more interactive workflow, faster answers. And what I didn't like when I was a data scientist is that locally I was working in Pandas, remotely I had to convert to PySpark. You don't want to run PySpark locally. You don't want Java in your environment. It's complicated. With Polars, we want to make this seamless, and we want to go from single node to multi-node in one API.
Are you competing with cloud providers in some sense? Because you can also, like on GCP, schedule queries, run them, and process your data. But then, as you said, you've got SQL in the cloud, and then you will have Pandas or another library like Polars on your locally.
I don't think so. It's also we also run the hardware from the cloud provider. So
okay,
I think for the cloud providers, it's sort of they're the big winners in the end.
Okay, so you run from the cloud providers, but everything is done in Polars essentially.
How do you mean? Sorry.
Like, how do you run Polar codes, like to process the data and everything, right?
Yeah. We're building our own engine that uses a lot from the open source engines. It's actually we're using the streaming engine in our workers, but we spin up. So currently we're only building for AWS. We're gonna do GCP and Azure later, but what we do is we have a control plane where you send your query. So let's say you have Polars on your laptop currently. You write your query, you write your lazy frame, and you say, okay, run this lazy frame remotely. Then we accept that lazy frame, that query. We see that you want this instance. We spin up that hardware for you, run that query, and write the result to S3 and give you back an object that sort of looks like a lazy frame, which points to that result we've written to S3, and then you can continue with that result.
What's a lazy frame?
A lazy frame is that's you can think of it like a data frame, but it isn't. But it looks like a data frame. So in Polars, we have two APIs, the eager and the lazy API. They look exactly the same, only one works on lazy frames, the other works on data frames. And if you run Polars on data frames, you don't get any benefit from the optimizer. You don't get any benefit from having a full-fledged query engine. So we always recommend people to use lazy frames. So if you're interactively working in a notebook, I would recommend you to use a data frame because you're just playing around. You want to see what data looks like. You want to do things one operation at a time and sort of get a feel of the data. But then you're writing your script, and then we recommend, okay, this script is written, but now the input type should not be a data frame, but a lazy frame. It doesn't change anything. It doesn't change anything on your script, but the data type has changed to a lazy frame, and what it means is it's a description of the query. It's a DAG of the computation. You can think of it sort of like an AST in a programming language, an abstract syntax tree, sort of the description of all the operations you want to do. And we call it lazy frame because it doesn't do anything until you say, okay, collect, fetch me the result. And then we start doing the work.
Okay, makes sense. So like I understand better your analogy of someone having to pick the fork and then
Yes.
and then a spoon and a knife. So what are your big challenges at the moment with Polars? What's on your roadmap for the coming months?
Oh man, there's a lot. There's a lot. There are a lot of things that are more complicated once you go distributed and a a streaming query engine as well. For instance, we mimicked the categorical type to pandas, but that type is very complicated to do in a streaming fashion. This is something we're gonna solve. One thing I'm enthusiastic about is, so what's on my mind is mostly the distributed engine. That's a hell of an engineering challenge, and that's also a lot of fun. So that's first and foremost, just making sure that we can do the whole API in a distributed fashion and in an efficient manner. And because of the flexibility of Polars, we didn't make it easy. So that's good for the users, a little bit bad for us, but eventually, once we solved all problems, it will also be good it's good for everybody. One thing that's on the roadmap is extension type. So Polars, what we want is let users have a lot of flexibility and control of what they want to do. So we initially started to support that with plugins that do that allows users to run expressions. So with plugins, users could write their own expressions, write them in Rust, have maximal performance, and they could hook them into the Polars query engine. And then it's similar, like you could extend Postgres with your own functions. And this is the same with Polars. You can write your own plugin, for instance, if you want to have some distance functions on strings, for instance, or you want to do something that's quite expensive, you don't have to write a Lambda, you can write your own plugins, and then it will run in parallel. It will have query optimization. It's as if it's native to the engine. The same we did for IO plugins. So that way people can write their own sources, write their own data sources that we as a library would say is too niche to be in a general purpose data frame library. That's something we also want to do with Sings, but another one here is extension types. Extension types would allow you to take Polars types and say, okay, let's say I have a struct with an X and an I value, or let's say I have a struct with an X. You can now say this struct is, for instance, a coordinate. That would be a new type, and you could. So it's sort of inheritance, but then you would say what kind of behavior it should support.
Okay.
So you could say, okay, this type should support the equal trait. So you can compare them. And if you can compare them, then you can use them in the join. I don't know if the type is sortable, but maybe a coordinate is also sortable. Then it should also implement the order. And if it's sortable, then we can run it in a sort as well. You could override the format, how it looks. And you could nest them. So you could put them in a list, in a nested list, and you would still get your coordinate type. Or nest even extension types. So the goal with extension types is, again, let users write their own niches. And it would also open up Polars usage for Geo, which I think is also a very good use case for Polars, which currently isn't supported because we don't have extension types yet.
How many are you in the team at the moment?
Currently, we're with 11.
Okay, wow. So quite still a decent team.
Yeah. We want to grow a little bit bigger though, but because we have a lot to do, and we're completely people bound. So
Are you still coding?
I'm still coding, but less and less. It's I cannot take the hardest problems that take weeks anymore because I'm on a lot of calls and but yeah, I'm still coding and yeah, it's still what I love to do.
So what's your day-to-day like if you don't code too much?
Well, I still code every day. So but I take less and less the hardest problems. So put like that. I know the whole code base, so I take the bugs that don't take a lot of time, maybe ask around for some design choices. But if it gets too much work, something that would take a week, then I need to hand it off to someone.
What are the other things you do except coding? Define the roadmap, help people solve problems.
Help people think of what we meet potential customers. But yeah, being on a podcast, just different calls, a lot of calls, and yeah.
Okay, great. I think we dived quite a lot into data manipulation. I just have two short career questions before we finish the episode. The first one is, if you had one advice for people to progress in their career, what would be your advice?
Do what you love, and what worked for me always was just do projects, do stuff that you don't do at your working day. Take some time for that, and if you love it, of course. That's so for programming. I just always love to do stuff I didn't know. Do a lot of projects, yeah. And it always felt that even though it didn't feel useful at that time, later it fell in its place.
And one book recommendation before we finish the episode. It can be anything. It doesn't have to be technical, but could be as well.
Yeah, that's hard. I don't read a lot of books, so I don't have any.
Nothing. An article then?
Yeah, neither. It's no, I'm not a
build stuff. You're
build
more
stuff.
into building.
Yeah. I watch a lot of YouTube videos, so let me think if I Source to See from Pat Brett. It's not for learning anything, but it's good slow TV. If you want to relax a little bit.
Great. Thanks a lot. Thanks, Ritchie. It was great to have you on the show and chat with you.
Okay.
Yeah, have a great evening, good weekend, and hope to catch up very soon.
Yes, thanks. You as well.